Hello and a very warm welcome to Science Monitor, your weekly update on what is happening in and around the country in the field of science, technology, research and innovation. With a special focus on India, we bring you the stories that have the potential to change the S&T landscape of the country and impact your life. From the physical mechanism behind the eclipsing of the millisecond pulsars to the science tour of the National Metrology Institute of India, we have plenty in store for you today. But first, let's begin with the headlines. Indian scientists identify the physical mechanism behind the eclipsing of millisecond pulsars. Seamless frequency coverage provided by the upgraded GMRT enabled the scientists to unravel the mechanism. Preparations for India International Science Festival 2021 in full swing. The festival will reflect the spirit and idea of Azadi Ka Amrit Mahotsav to mark the 75th year of India's independence. We'll take you on a science tour of a CSIR National Physical Laboratory situated in New Delhi, also known as National Metrology Institute of India. The premier lab will soon complete 75 years of its establishment. And from a new system to protect the power grids from short circuits to living robots that can reproduce, we'll see more of such interesting developments in our segment Science Express. Well, now the stories in detail. Using the upgraded giant meter wave radio telescope near Pune, a group of scientists has now identified the physical mechanism behind the eclipsing of low-frequency radio signals emitted by a spider millisecond pulsar. The work has recently been published in the Astrophysical Journal, and according to the researchers, seamless frequency coverage provided by the upgraded GMRT has played a very crucial role in this discovery. Let us see this report for more details.
The giant meter wave radio telescope, situated close to Pune, has completed 20 years since its commissioning in 2001. With its sensitivity significantly improved after the completion of its major upgrade in 2018, the facility has become more powerful and versatile to probe various interesting objects in the universe, including the pulsars. A pulsar is a rapidly spinning neutron star having a strong magnetic field. It emits radio waves like a beacon, and whenever this beam crosses our line of sight, radio telescopes like the GMRT detect and capture the radio waves, and we see a pulse or flash of radio signals. When displayed, these signals look similar to the heartbeat ECG signal, going up and down once every time. Now a group of scientists at the National Center for Radio Astrophysics, TIFR Pune, has conducted a study to understand the eclipse mechanisms for the millisecond pulsars in compact binary systems using the upgraded giant meter wave radio telescope. Millisecond pulsars are often compared to atomic clocks as they send periodic flashes of radio light as fast as a few hundred times in a second. They often exist in binary systems along with a star. In a compact binary, as the distance between the two is quite less, so charged radiations from MSPs often blow away the material from the companion star. This blown-off material hides the low-frequency radio emissions, causing an eclipse.
Pulsars are rapidly rotating neutron stars, and some pulsars which have periodicity very fast, which is in millisecond range. Most of these are in binary systems, and for some of the compact millisecond pulsars having periodicity in millisecond range, for majority of them these are in binary system, and for some of these systems they are in very compact binary, and we see eclipsing in those.
For the solar or lunar eclipse, the object which is blocking the radiation or the light, that is a solid object. But in this case, the material which are outside the companion, which is ablated from that companion, that is blocking. And due to this reason that the low frequency of the emission from the millisecond pulsars are generally blocked, but the high frequencies can, at that same stage, the high frequency can still be observed.
Although eclipsing of MSPs is known since the 1980s, yet the exact physical mechanism behind this phenomenon was not known. To understand this mechanism, researchers studied a spider millisecond pulsar named J1544 plus 4937. The unique wide bandwidth sensitive observations of the upgraded GMRT allowed the authors to clearly measure how the eclipse depends on the radio frequency, particularly during the transitions as the pulsar went into and came out of eclipse.
Due to the seamless coverage, we can first time actually can obtain the spectrum, that is the intensity of the pulse emission as a function of frequency. And we used the spectrum when the pulsar is, when the companion is not in our line of sight, and also the spectrum when the companion is at our line of sight. We use this both the spectrum, and this actually allows us first time to determine what is the actual physical mechanism that is causing this eclipse.
The researchers found that the absorption by the magnetized materials ejected from the companion star was causing the eclipse in case of J1544 plus 4937. The upgraded features of the GMRT enabled the researchers to study for the first time the actual cause of eclipsing in this system.
This is just one glimpse of the kind of science that is done with the GMRT. There are many other areas of frontline research. Today, I think the total user base of GMRT has people from more than 35 countries who have used the GMRT. And every year, we get a lot of proposals for the projects that can be done with GMRT.
Over the years, GMRT has been used to study a whole range of different phenomena and objects in the universe, starting all the way from our sun, to looking for planets around other nearby stars, to exploring various phenomena in our as well as faraway galaxies. And now to the upgraded GMRT, the whole range of this vast universe has become more accessible.
And preparations for the IISF 2021 are in full swing. Recently, a curtain raiser event was organized at the Prithvi Bhavan Auditorium in New Delhi for the 7th edition of this festival. The festival holds immense significance this year as India is celebrating the 75th year of independence, and IISF 2021, to be organized in Panji from 10th to 13th of December, aims to play an important role in India's action plan for the next 25 years. Here's the report.
The countdown for the 7th India International Science Festival, IISF 2021, has begun. The Mahakumbh of Science is being organized in Panaji, the capital of Goa, this year from the 10th to the 13th of December. After the formal announcement of IISF 2021, a series of curtain raiser programs have now been launched. As part of this, a program was organized last week at the Prithvi Vigyan Bhavan Auditorium in New Delhi. The Union Minister of Science and Technology and Earth Sciences, Dr. Jitendra Singh, Secretary, Ministry of Earth Sciences and Department of Science and Technology, Dr. M. Ravichandran, Secretary of the Atomic Energy Commission, K.N. Vyas, and officials related to various departments were present. Dr. Vijay Bhatkar, Chairman of Vigyan Bharati and Director General of CSIR, Dr. Shekhar C. Mande, joined the event virtually. Releasing the outline of the festival at the event, Dr. Singh said that in India, science is now accepted not only as a subject of research, but also as a festival. Therefore, the need of the hour is to take the science festival to every city and village of the country.
आने वाले कुछ एक वर्ष हमारे लिए बड़े महत्वपूर्ण रहने वाले हैं, क्योंकि 25 वर्ष के बाद जब भारत विश्व पटल पर प्रथम स्थान पर खड़ा होगा और स्वतंत्रता की 100वीं सालगिरह मना रहा होगा और ये आकलन किया जाएगा कि इस सफल यात्रा के पीछे क्या राज रहा, तो मुझे लगता है कि इसका सर्वाधिक योगदान दिया जाएगा हमारी वैज्ञानिक क्षमता को और भारतीय वैज्ञानिकों की अभूतपूर्व प्रतिभा को।
IISF aims to acquaint the young generation with the science and technology achievements of India, igniting their creativity in the process. Instilling creativity in the younger generation will give rise to indigenous innovations and bring ease of living to society at large. In its previous edition, IISF successfully achieved this goal by reaching out to a large number of people despite the roadblocks caused by the pandemic. It is expected that the 7th edition of IISF will also reach a large number of students, youth, teachers, researchers, scientists and general public. This year's festival has 12 events tailored to various themes and upcoming challenges.
IISF 2021 जो 7वां एडिशन है IISF की इस यात्रा में, वो गोवा में होने जा रहा है 10 से 13 दिसंबर। इस समय की थीम है क्रिएटिविटी इन साइंस, तो इसको लेकर ये उत्सव पूरा होने वाला है। इस समय की विशेषता ये है कि आज़ादी के अमृत महोत्सवी वर्ष में इस IISF को मनाया जा रहा है। स्वाभाविक है इस विज्ञान के उत्सव में भी इन्हीं बातों का विचार करके कार्यक्रमों की योजना बनी है। आप सबका इस विज्ञान के अंतर्राष्ट्रीय महोत्सव में हार्दिक स्वागत करता हूँ।
Creating Guinness World Records has been an interesting tradition at IISF, providing information as well as practical inspiration to students. IISF has set world records in each of its editions. In the upcoming 7th edition, 3 exciting activities will be attempted to make the Azadi Ka Amrit Mahotsav memorable. To mark the 75th year of India's independence, IISF programs have been classified into 5 categories: Ideas at 75, Achievements at 75, Actions at 75, Resolves at 75, and Freedom Struggle. The goal of these activities remains the same: to take India to the forefront of every field.
The New Delhi-based CSIR National Physical Laboratory was established in January 1947 to strengthen and advance physics-based research and development in the country. Today, it is also serving as the National Metrology Institute of India, being the custodian of the national standards of measurement. Let us take you on a science tour of this premier laboratory to witness the different SI units of measurement kept and maintained by the CSIR NPL.
For most of us, the daily routine begins with a look at the clock to know the time. As we get through the day, measurements and weights are used several times when we cook, bake or buy groceries. The change of seasons is also established by measuring the temperature. But have you ever wondered how these measurement standards remain precisely the same throughout the country for instruments like clocks, thermometers and weighing scales? That's where the National Physical Laboratory of India comes in. This institute, under the Council of Scientific and Industrial Research, is located in New Delhi and maintains the national standards of measurements. As it generates the Indian Standard Time, so it is also known as the Timekeeper of India. NPL is tasked with establishing, maintaining and continuously improving by research the national standards of measurements and realizing the units based on the international system. Through precision measurements, calibration, development of devices and processes, NPL is providing essential services to industries and national agencies. NPL has 8 of the world's 400 atomic clocks. These are maintained by the Time and Frequency Division of the laboratory. It ensures uniform time across the country. On the 75th Foundation Day of NPL this year, the National Primary Time Scale of India, generating Indian Standard Time with an accuracy of 2.8 nanoseconds, was dedicated to the country.
Here we generate the Indian Standard Time, which is based on bank of cesium atomic clocks and active hydrogen maser. Our time scale, which is called UTC NPLI, is based on time scale called UTC generated by BIPM in France. We not only contribute to the international time scale, but also generate the Indian Standard Time, which is disseminated to strategic sector, to banking sector, to power grid, to all the telecom and internet service providers.
The mass metrology section of the NPL preserves the prototype of the kilogram. This cylinder, made of 90% platinum and 10% iridium metal, was the international prototype of the kilogram until the new definition of the kilogram was adopted. Apart from this, other parameters of weight are also present in the laboratory. Their preservation, maintenance and improvement are now done using state-of-the-art technology.
At NPL, we have two responsibilities. One is to provide the traceability to the RRSL. There are 5 regional standard laboratory in India. Every 3 years, we provide traceability to the RRSLs, and further they disseminate to the other shop floor to maintain the weights and measures system of the country. And another, also we provide various strategic sectors, pharmaceutical industries and other scientific fields.
Another important section concerns length and dimension metrology. In this division of NPL, the precise standards of length and dimensions are studied and preserved. These standards are not only used by industries but also by the general public in their daily lives.
Here in our section, we provide traceable calibration services to various customers across country and also to SAARC nations. We realize the SI unit of length meter with the help of this primary standard, which is an iodine stabilized helium neon laser working at 633 nanometer wavelength. Primarily using this primary standard, we calibrate the laser heads which are used in interferometry for the dimensional measurements. So whatever dimensional measurements are being conducted through interferometry, the laser heads are being calibrated here with this primary standard.
The scientists at NPL also do the difficult task of maintaining and improving the measurement standards for temperature and humidity. The apex level calibration in temperature metrology is available in the laboratory in the range from -200 degrees Celsius to 3000 degrees Celsius.
We have established the primary standard of temperature, which is triple point of water, which is defined at 273.16 Kelvin, and in international temperature scale of ITS 90, we have defined fixed points from boiling point of liquid nitrogen up to 962, which is freezing point of silver.
The amount of light emitted by light bulbs and other equipment used in our day-to-day life is determined and verified by the Optical Radiation Metrology Division of NPL.
This is our luminous intensity measurement setup. And the basic thing here, we can calibrate the luminous intensity of any light source. This is our measurement standard from where we are giving traceability to the customers who are involved in the light industry. They are giving our sample like standard light source and CFL LEDs, and we are giving traceability to them.
We all see volt and ampere meters, but how exactly are these standards of current determined? This is done using the quantum standard of voltage at NPL. The Electrical and Electronics Metrology Division also deals with other parameters that are crucial for the electrical and electronics industries.
This is Programmable Josephson voltage standard. It is the quantum standard of voltage, and it is recognized as the primary standard of voltage at NPLI. It is used to provide traceability services for the dissemination of SI unit volt throughout nation. It serves as the backbone for the electrical and electronic industries.
Csir NPL is offering dissemination of apex calibration facilities not only to Indian industries, strategic sector and academia and government agencies, but also to SAARC and other nations. Owing to its untiring efforts on precision measurement and its dissemination, Csir NPL has occupied a pivotal position in the all-round development of the country.
And now it's time to have a quick look at some other developments that have made news in the field of science and technology in our segment Science Express.
Indian researchers have evaluated the real-world vaccine effectiveness of Covishield against the Delta variant of SARS-CoV-2. The rise in mutant variants of the SARS-CoV-2 virus has led to concerns regarding vaccine effectiveness, and with the vaccination program in India mainly being driven by CHAdOX1, nCoV-19 or Covishield, a multi-institutional team of Indian researchers led by the Translational Health Science and Technology Institute assessed the actual effectiveness of the vaccine between April and May 2021. According to this comparative study published in the journal The Lancet Infectious Diseases, the vaccine's effectiveness was found to be 63% in fully vaccinated individuals, while the effectiveness of complete vaccination against the moderate to severe diseases was much higher at 81%. The scientists found that the spike-specific T-cell responses were conserved against both the Delta variant and wild-type SARS-CoV-2. Researchers from the Indian Institute of Technology, Kanpur, have developed a prototype of a smart system that can protect power grids from short circuits. The prototype works by either automatically diverting the current into a parallel shunt or limiting a current surge by developing high resistance in the current path. Short-circuit conditions often also occur in power distribution networks such as power grids, resulting in huge current surges that can damage the power. In recent years, a new fault current limiter technology has been developed. Using superconductors called superconducting fault current limiters, an Indian researcher has now developed a unique innovation of a prototype of a smart superconducting fault current limiter, which has a circuit wherein a superconducting element has an array of Hall sensors distributed around the superconductor. Developed with the support of DST's Advanced Manufacturing Technologies program, it is in the fourth stage of the preparation stage, and a national patent has also been filed for it. The homegrown technology of biojet fuel production developed by CSIR's Indian Institute of Petroleum, Dehradun, has formally been approved for use in military aircraft of the Indian Air Force. This certification represents India's growing confidence in the aviation biofuel sector and is another step towards Atmanirbhar Bharat. Fuel, being the lifeline of aircraft, requires thorough analysis before being filled into manned flying machines. That's why this technology has been extensively evaluated and tested over the past 3 years. This approval has been given by the testing agencies after various ground and in-flight tests. Compared to conventional jet fuel, this green fuel will reduce air pollution and contribute to India's net zero greenhouse gas emission targets. Scientists who created the world's first living robots, Xenobots, have now claimed that these robots can reproduce. Last year, scientists from Tufts University, University of Vermont, and Harvard University in the US unveiled these robots that were created using stem cells from the heart and skin of an African clawed frog. They have now discovered that these robots can move, work together in groups, and self-heal. However, their method is different from any reproductive methods seen in plants or animals. These computer-designed robots, smaller than a millimeter, can swim in their environment and find other single cells to form baby Xenobots. The scientists highlighted that robots are often thought to be metal or ceramic, but what they do is more important to define them as robots rather than the material they are made from. The new discovery may prove to be very beneficial in regenerative medicine.
And that's all in today's edition of Science Monitor. You can send us your feedback and suggestions through email. Our email ID is indiascience@vigyanprasar.gov.in. You can also write into us at Vigyan Prasar, A50, Sector 62, Noida 201309, Uttar Pradesh. So we'll take your leave now. See you again next week. Till then, stay safe and think scientifically.